Okay, so the last two are mainly just going to be more for like Calc 2. So if you're thinking you're going to pass the AP test, I would say it's good for you to see these, but I wouldn't necessarily expect you to be able to like reproduce these on your own. So look at the first one. We have the integral of sine cubed 2x. We're going to use the first identity that sine squared can be subbed out to be 1 minus cosine squared 2x. So the first thing that I'm going to do is I'm going to split this up into a sine squared times another sine. So altogether, I originally had 3. Now I have 2 and 1, so that still counts as 3 altogether. Then we're going to split up the sine squared 2x. We're going to replace it with this. So that's going to replace the sine squared in the equation. So now it's 1 minus cosine squared 2x, and then still times sine 2x at the back, dx. Okay, so all that happened in that step is that I took this expression and I subbed it in where my sine squared was here in the original equation. So I replaced those two things so that now I have 1 minus cosine squared 2x times, and then I'm leaving that third sine 2x the same. Okay, we're going to do u sub. For our u, we're going to pick cosine 2x. Now, we are not going to pick the squared. Then du dx is the derivative, negative sine 2x times 2. Now remember, why did we have to do this times 2? Because of chain rule. So since it was a 2x in the middle, that's why we put the extra times 2 in the front. Okay, then I'm going to move my dx up. I'm going to move my negative 2 sine 2x down, so that dx equals du over negative 2 sine 2x. Okay? Then from there, we're going to rewrite our integral. So it'll be 1 minus, then remember that this here is my u, but it's squared. So 1 minus u squared. And then I'm going to have my sine 2x. And then my dx is now a du over negative 2 sine 2x. Okay? Then from there, I notice that I have a sine 2x on top and a sine 2x on bottom. Those can cross out. But this extra negative 2 is going to have to move to the outside. So really now I have negative 1/2 1 minus u squared du. Okay? From here, we're doing the antiderivative. The integral of 1 is going to be 1u. The integral of u squared is going to be 1/3 u cubed. Okay, and then remember that both of these guys, they had originally been in parentheses, so I'm going to keep them in parentheses with my negative 1/2 out here in the front. Okay, so remember that that negative 1/2 applies to the entire integral. Okay, and then also I have a plus c. Then for my last step, I'm going to distribute my minus 1/2. So that would be negative 1/2 u plus 1/6, because I'd be doing 2 times 3 on the bottom, u cubed plus c. Now, you might be wondering, how do I know if I include the c in the antiderivative or not? The real reason is it doesn't matter. If you want to put the plus c inside the parentheses, you can, but it's just kind of unnecessary because c is already unknown. So think about, if this is unknown and then I times it by negative 1/2, well, I still don't know what it is, so it doesn't really matter what I call it. Okay? Then from there, I'll have negative 1/2. My u was a cosine 2x plus 1/6 cosine 2x cubed plus c, and that'd be your answer. Okay? So obviously that's a little bit harder than what we're doing in class, but you're really not going to see those on the AP test. The bigger thing would be just having a little bit of exposure to them so that when you do get to Calc 2, you're not totally like, what the heck is this? Okay, come up to number 21. Number 21 is a little bit weirder. So, first thing I'm going to do is I'm going to take my tan to the 4th and I'm going to split it up into a tan squared x times a tan squared x. Now, why am I splitting them up? Well, remember that my identity up here says that I can replace tan squared with secant squared minus 1. So I'm going to take one of the tan squareds. It really doesn't matter which one. I'm going to happen to use this one. And I'm going to take the tan squared out, and I'm going to plug in the secant squared x minus 1. So I now have this. Tan squared x times, secant squared x minus 1 dx. Okay? So far, so good? Okay, then I'm going to take my tan x, and on this one, I'm going to distribute that times the secant squared and then times the minus 1. So now I have this. Tan squared x times secant squared x. And then minus, when I times the tan x with the 1, it's now a minus tan squared x dx. Okay, the second thing that I'm going to do is I'm going to split this up into two integrals. So I'm going to work this as one integral, and then I'm going to work this as its own separate integral. So let's do this integral first. My u is going to be tan x, which makes my du dx secant squared x. Then I'm going to take my dx up. I'm going to take my secant squared x down, so that now dx is going to be du over secant squared. Okay, now we're going to rewrite. Remember, we're just mainly dealing with this one integral right here. We're kind of not really looking at this for now. So it's going to be the integral of, remember that u is tan, so this is u squared secant squared x du over secant squared x. Okay, so that's my first part. And then I notice my secant squareds cross out, just like we would need them to do for us to be able to integrate. And then the antiderivative, or the integral of u squared du, is going to be 1/3 u cubed. Now remember that technically there's a plus c involved here, so I'm going to go ahead and make it 1/3. My u is now a tan x, remember. So tan x cubed, and then I'm going to put my plus c way over here, because I know that I still have this whole separate integral up here that I need to do. Okay, now if I picked my u to be a tan x on this one, remember that in order for me to have u as my tan x, I would have to have a secant squared to cross out with the secant squared from here. So instead, what I'm going to do is I'm going to substitute a second time. Okay, remember that tan squared has this rule right here. Tan squared is the same as secant squared minus 1. So I'm going to rewrite this as minus 1 integral, and then my tan squared is now a secant squared x minus 1. Now, just to keep things easy, I'm going to distribute this minus 1 just so that it's not in the front. So instead of having a secant squared, now I have a minus secant squared x, and instead of having a minus 1, now it's a plus 1 dx. Now you might be wondering, well, why would I do that? Okay, the integral of tan squared doesn't have a rule, but there is an integral for secant squared. So if you remember, the derivative of tan is secant squared. Well, then the integral of secant squared is going to bring me back, oops, I should have still put that, to negative tan x. So if I switch it to a secant squared, I have a rule that will help me do the antiderivative of that, versus if I leave it as a tan squared, there's no rule for that. Okay, then from there, the antiderivative of plus 1 is plus 1x. And then I'm basically going to take that chunk and I'm going to insert it down here into my final answer. Okay, so I didn't need u sub on that second part. I just switched it out using the identity, and then I used the integral of secant squared to be tan x. So it'd be 1/3 tan x cubed minus tan x plus 1x plus c. And that would be your answer. Okay? Good job.